Hello everyone, I hope all of you are having a great time and let's quickly walk through today's question. Today's question is middle of the linked list. Here we are given a linked list and we need to identify the middle node of the linked list. For the cases where there are two middle nodes, we need to return the second one. I'll be talking about these examples by the presentation. So let's quickly move on to the PPT. Also, for those who have been following me from a long time, they don't need a video for this. I'm making this video who are new onto this channel. So let's quickly walk through the approach and I'll be talking about two solutions here. One the naive one and the other one is the known as the interesting one. Middle of the linked list, Leetcode 876. It's an easy level question on Leetcode and I totally feel the same. So let's take the same example that was specified in the question where the length is odd. We have 5 elements in total. The middle element is 3 and we need to return 3 node as a final answer. So let's forget fast pointer, slow pointer approach for a second. Let's talk about the naive typical approach that comes to everybody's mind when they read this question for the first time, given the fact that fast and slow pointer is not known to them. So what do? We count the number of nodes present in the linked list. So let's start the iteration. We start the iterator and the iterator is responsible for iterating over all the nodes in the linked list. Also, we maintain the length variable, and as we are progressing over the linked list, we increment the length variable. Once we have iterated over the linked list, the length variable will store 5. 1, 2, 3, 4, 5. Now we know that the length has come out to be odd in nature. So what do? We divide this by 2 and add 1 to it. So len by 2 plus 1 is the node where we actually will get our middle element. So this comes out to be 5 by 2 is 2, 2 plus 1 is 3. So we need to reach the third node of the linked list. We start the iteration. We have taken another pointer, it, and it is responsible for moving up till 3 nodes. So here right now it is at the first node, next and followed by this one. Here it has reached the middle pointer node and we simply abort the process and return this value as a final answer. Pretty simple and straightforward. The time complexity of this approach is order of n. You are traversing the linked list twice, one for identifying the length of the linked list and other for reaching the middle element. Can we avoid this 2 times traversal, although it won't impact the time complexity? But still, can we avoid it? Yes, we can. How? Let's talk about it. We'll use the fast and the slow pointer approach. So in fast and slow pointer approach, the fast pointer moves by 2 positions and slow pointer moves by a single position. So let's take and create 2 pointers, one known as fast, other known as slow. So let's start the iteration. Let's move the fast pointer up till 2 positions. First hop, second hop. So fast reaches here. And slow moves by a single position. Slow reaches here. Let's again do the same thing. Let's increment fast by 2 positions. 1, 2. So fast moves here and slow moves here. So what do we observe? We see that fast has reached the terminal node. Fast.next happens to be the ending of the linked list, and whatever position slow pointer is at, we simply return that back. Where it is at 3, which is in sync with our expectation. 3 points, slow points to the middle element. So by a single iteration, without identifying the length of the linked list, we have successfully reached the middle point. It's pretty simple and straightforward in analysis. Fast pointer is making 2 hops, whereas slow pointer is making a single hop, as a result of which fast will be 2 times ahead than the slow pointer, and this forms the basis of fast and slow pointer technique. Let's walk through the other case where the linked list has even number of nodes. The first approach is pretty simple and straightforward. What do? You identify the count of nodes that are present in the linked list. The length turns out to be 6. You apply the formula length by 2 plus 1. So what is length by 2? Length by 2 is 3. 3 plus 1 is 4. So what do we need to do? We need to move the iterator up till 4 positions. 1, 2, 3 and 4. This gives us the middle element by the first approach. Let's talk about the fast and the slow pointer approach. Fast pointer moves by 2 positions, slow pointer moves by single position. So let's start. We have a fast pointer here, we have slow pointer here. So fast moves by 2 positions, 1, 2. So fast gets here, slow gets here. So we have F here, we have S here. Fast again moves by 2 positions, slow moves by a single position. Now again, fast.next is not equal to null. We have not reached the terminal state. What do? Fast moves by 2 positions and slow moves by a single position. 1, 2. So fast moves by 2 positions and slow moves by a single position. Slow points to 4, and we have successfully reached the middle element. Pretty simple and straightforward. Again, the time complexity of this approach is order of n, because fast pointer is moving across the linked list up till the ending of the list. The space complexity of this approach is constant space. We are not using any extra space for solving this up. Now let's walk through the coding section, and I'll be talking about the fast and the slow pointer approach. I want you guys to fill in for the first approach. If you are interested, do give a submission via pull request on GitHub, link attached below. The code is pretty simple and straightforward, quite easy to understand. I have created 2 nodes, fast pointer, slow pointer. If my head happens to be null or head.next happens to be null, that means either the linked list is null or it only has a single element, then I simply return back the head of the linked list, because I really don't need to do anything. Otherwise, I go and create the fast and the slow pointer, and both of them point to the starting nodes. Till the time my fast pointer is not null or fast pointer.next is not null, what do? I increment the fast pointer to the next node. If my fast pointer is not equal to null, I again increment the fast pointer to the next node. What do you see here? You see here that the fast pointer is moving by 2 nodes, whereas the slow pointer is moving by a single node, as talked in the presentation. Once I'm out of the loop, I simply return the slow pointer. Let's try this up. 100% faster, pretty good. The time complexity, as I've already told, order of n, whereas the space complexity is constant space. This brings me to the end of today's session. I hope you enjoyed it. If you did, please don't forget to like, share and subscribe to the channel. Thanks for viewing it. Have a great day ahead and stay tuned for more updates from Coding Decoded. I'll see you tomorrow with another fresh question, but till then, goodbye.